Hi, I'm Ethan. Recent astronomy news may refresh what we think we know about the universe. Thanks for liking, subscribing, and supporting the channel. First story. On Earth, cloudy with light rain sounds normal, but on this alien planet, rock clouds in the morning, clear skies in the evening, and an average temperature above 1500 Kelvin or 1200 degrees Celsius. That is pretty wild. This planet is called WASP-94A. It's a hot Jupiter, a giant gas planet orbiting very close to its star. The data came from the James Webb Space Telescope. The study was led by Sagnik Mukherjee from Johns Hopkins University and posted on ARKiv in May 2025. But Webb didn't photograph the clouds directly. Scientists used transmission spectroscopy. In simple terms, when the planet passes in front of its star, some starlight travels to the edge of its atmosphere. Different gases, clouds, and particles leave different fingerprints in the spectrum. It's like reading a medical report for an alien world and using it to figure out what's in the atmosphere. And the result was surprising. The morning side looked cloudier, while the evening side looked much clearer. To be clear, Webb didn't watch clouds drifting like a weather satellite. This was inferred from the spectrum by comparing the planet's morning and evening edges. So what are these clouds made of? At such high temperatures, they can't be water clouds. They are probably mineral clouds, made of silicates and iron particles. In simple terms, rocky material may vaporize, form cloud particles, and get carried by powerful winds. On Earth, water evaporates and forms clouds. On this hot Jupiter, rocks may vaporize, form clouds, and disappear again in hotter regions. The universe is full of surprises. Second story, wandering binary planets. When we think of planets, we usually imagine them orbiting a star. Earth orbits the Sun. Jupiter orbits the Sun. That feels obvious. But the universe does not always follow human intuition. Astronomers have found that there may be many planet mass objects that do not orbit any star. They are called free-floating planets or rogue planets. They have no sun, no stable day and night, and they drift alone through the Milky Way. But this new discovery is even more interesting. The study was led by C. Caceres and colleagues and published in Astronomy and Astrophysics in April 2026. Near the Lower Centaurus-Crux Association, the team found possible pairs of planet mass objects. No sun, no star, just two cold, young, massive worlds, keeping each other company in the dark. Objects like these are sometimes called jumbos, short for Jupiter mass binary objects. More precisely, they are candidates for free-floating planet mass binaries. The data came from Gaia, VVV, VVVX, and DECAPS. The team did not directly film two planets orbiting each other. Instead, they found two faint objects with similar distance, color, brightness, and motion. So they do not look like random background stars lined up by chance. They look more like a pair of rogue planet candidates, possibly bound by gravity. So, how did they form? There are two possibilities. First, they may have formed inside a normal star system and were later kicked out by gravitational chaos, a cosmic version of being thrown out of the house, but at least the two brothers stayed together. Second, they may not have formed in a planet disk at all. Instead, they may have collapsed directly from a gas cloud, like stars and brown dwarfs do. They were just too small to ignite nuclear fusion. And that creates a tricky question. If an object has the mass of a planet but forms like a star, is it a planet or just a very unsuccessful tiny star? Third story, an overgrown early black hole. If I ask you, which came first, the galaxy or the supermassive black hole? Traditionally, we would probably say the galaxy came first. A galaxy has many stars. Massive stars die and form black holes. Small black holes keep feeding and merging and eventually grow into the supermassive black holes at the centers of galaxies. That logic sounds pretty reasonable. But after Webb looked into the early universe, the story became much less simple. Researchers from Cambridge, Florence, and other institutions used Webb's near-infrared spectrograph, NIR-SPEC. The related studies were published in Nature and monthly notices of the Royal Astronomical Society. One recent target has received a lot of attention. It's called Able 2744 QS01. It comes from the early universe, about 700 million years after the Big Bang. It is extremely distant, but in front of it lies a massive galaxy cluster, Able 2744, also known as Pandora's cluster. Its gravity works like a natural magnifying glass, making the background object easier for Webb to see. Scientists used Webb's near-infrared spectrograph to study gas moving near the center of this object. From that motion, they estimated the hidden central mass. The result was surprising. The black hole is about 50 million solar masses. Even stranger, it may make up a huge fraction of the entire system. In today's universe, a central black hole is usually only a tiny part of its galaxy. For example, Sagittarius A star, at the center of the Milky Way, is about 4 million solar masses, but the Milky Way itself has more than 1 trillion solar masses. They are not even on the same scale. But this early object looks almost reversed. It does not look like a galaxy with a black hole inside it. It looks more like a giant black hole, barely wrapped in a small, still growing galaxy. This strongly suggests that some early black holes may not have grown slowly from ordinary small black holes. Instead, they may have started with a massive black hole seed. That seed may have formed when a huge gas cloud collapsed directly, or through some other unusual process in the early universe. Either way, astronomers now have a serious headache. The problem is time. Only a few 100 million years had passed since the Big Bang, but this black hole had already grown to tens of millions of solar masses. That's like a child finishing a PhD before leaving kindergarten. This is where Webb is so powerful. It lets us look into the early universe, but what happened in those first 700 million years? That still needs more research. So, these are 3 recent astronomy stories that may refresh how we understand the universe. If you enjoyed this video, please give it a like, subscribe, and turn on the notification bell. Your support means a lot to our original content team. This is Rooftop Astronomy. I'm Ethan. See you in the next video.